Hello students, this is our next topic of quantitative techniques. In this topic, we will study about the sensitivity analysis of an LPP. In the earlier classes, we have studied about the LPP characteristics, methods to solve the LPP, and the last topic was duality. Now, this topic, sensitivity analysis, as the name is given as sensitivity, that means how my solution is sensitive. So, we have to see the effect of the change in the solution if we are changing the right hand side of the constraint or the objective function of the constraint, or we change the matrix of the coefficients. So this sensitivity analysis is basically very much important in the business because we have the resources and we want to see that how we can change the resources to get the profit. So in this topic we will study about the sensitivity analysis. So the three objectives of this topic is sensitivity analysis, effect of the change in the right hand side of the constraints, effect of the change in the coefficients of the objective functions. So these three are the objective of this lecture. So first we have to understand that what is a sensitivity analysis. As the name suggests, that sensitivity. It means that my solution is how much sensitive. So I have to do the analysis of that. So sensitivity analysis deals with finding out the amount by which we can change the input data for the output of our linear programming model to remain comparatively unchanged. Basically, what we want that the solution should not be changed. But if the solution is changing, that how much it is changing and what is the change in the output. So we have to find out this thing. This helps us in determining the sensitivity of the data we supply for the problem. If a small change in the input, that is for example in the change of the availability of the some raw material, produces a large amount change in the optimal solution for some model, and a corresponding small change in the input for some other models doesn't affect its optimal solution as much, we can conclude that the second problem is more robust than the first. That means second model is less sensitive to the change in the input data. To understand the sensitivity analysis and the shadow prices. Shadow prices are basically then when we are changing the right hand side of the constraint and what is the change in our output. How much we are getting the more profit or the less profit, that is the shadow prices. So in the sensitivity analysis, what we have to understand, we have to see that how our
Sensitivity
data is
analysis
changing
is
and
used
how
to
we are
answer
getting the
two
optimal
types of
solution. So
questions. The
you
first
can watch
one
the
is,
video.
how do the changes in the available resources affect the optimal solution? The available resources are represented by the right-hand side in the constraints. The second one is, how do the changes in the unit profit or unit cost affect the optimal solution? The unit profit or unit cost are represented by the coefficients in the objective function. Here is an example. Two machines are used to produce two types of products. A unit of product 1 requires 2 hours of processing time on machine 1 and 1 hour of processing time on machine 2. A unit of product 2 requires 1 hour of processing time on machine 1 and 2 hours of processing time on machine 2. Daily processing time available on each machine is 8 hours. Selling 1 unit of product 1 will generate $300 net profit. Selling 1 unit of product 2 will generate $200 net profit. Now we let x1 be the number of product 1 produced, and x2 the number of product 2 produced. We can formulate a linear programming problem to maximize the daily profit, which is the total profit of selling products 1 and 2. The first constraint means that the total processing time on machine 1 should not exceed 8 hours. The second constraint means the total processing time on machine 2 should not exceed 8 hours. This problem has only two variables. We can solve it graphically. This is the constraint of machine 1, and this is the constraint of machine 2. This shaded area is the feasible region. This point A is the optimal solution. The objective function value at this point is 4000 over 3. Now let's perform sensitivity analysis on the right-hand side of the constraints. For machine 1, we want to know if we change the available time by 1 hour, from 8 to 9, how much will the z value change? In this graph, the constraint for machine 1 will be changed to M1 prime, and the optimal solution will be changed to point B. The objective function value at this point is 4,400 over 3. The shadow price of machine 1 is defined as follows. The new z value minus the old z value divided by machine 1's capacity change. So the shadow price of machine 1 is $133 per hour. It means each hour increase on machine 1 will bring in 133 more profit. For machine 2, we can do the same. We want to know if we change the available time by 1 hour from 8 to 9, how much will the z value change? In this graph, the constraint for machine 2 will be changed to M2 prime, and the optimal solution will be changed to point C. The objective function value at this point is 4,100 over 3. The shadow price of machine 2 is the new z value minus the old z value, divided by machine 2's capacity change. So the shadow price of machine 2 is $33 per hour. It means each hour increase on machine 2 will bring in $33 more profit. Now we have the shadow prices of these two machines. Based on these shadow prices, let's answer these questions. First question, if we can increase the capacity of both machines, which machine should receive priority? The answer is machine 1, because if we increase both machines' processing time by 1 hour, the increased profit from machine 1 is much higher than the increased profit from machine 2. Second question, should we increase the availability of machine 1 at an extra cost of $50 per hour? The answer is yes, because $133 is greater than $50. We will still make more money by increasing the availability of machine 1. What about machine 2? The answer is no, because $33 is less than $50. We will lose money and it's not worth it. Now let's perform sensitivity analysis on the objective coefficients. For general maximization problem, z is equal to c1 x1 plus c2 x2. The slope of the objective function is minus c1 over c2. This slope should be between the slope of these two constraints, so that the optimal solution will be unchanged. That means the optimality range of c1 over c2 is between 1 over 2 and 2. With that in mind, let's answer this question. Suppose that the unit profit for product 1 is changed to $350, and the unit profit for product 2 is changed to $250. Will the current optimal solution remain the same? To answer this question, let's check the value of C1 over C2, which is 350 over 250, or 7 over 5. It's still between 1 over 2 and 2. So the answer to this question is yes. Another question. Suppose that the unit profit of product 2 is fixed at its current value. C2 is equal to $200. What is the range of the unit profit for product 1, C1, that will keep the optimal solution unchanged? Now C1 over C2 is C1 over 200, which should be between 1 over 2 and 2. Finally, we have that C1 is between 100 and 400. If it's in this range, the optimal solution will remain the same. Okay, that's how to perform sensitivity analysis for linear programming problems and how to use the results to make managerial decisions. Thank you for watching.
So as a recap of the lecture that we have studied about the sensitivity analysis, that what is the meaning of sensitivity analysis, and in the video we have seen that how what is the change in the objective function value, or what is the change in the solution if we change the right hand sides of the constraint. And the second is, we have also seen that if we change the objective function, that what is the change in the solution. Also we have seen that if we don't want to change the solution, what is the range of the one variable which we can carry out. So that means that what is the range in which if we change the value of the coefficient of our objective function, the solution doesn't change. So the following question comes in the mind: what is sensitive analysis and what is the application of the sensitive analysis? So the application of the sensitive analysis is basically that we have to find out that how much profit or how much we can earn extra, or how much the profit we can get extra if we are changing the one unit of the resources. So that is the application that we have to find out. So these are the resources, or these are the references which can be referred to find out the more detail on the sensitive analysis. The first book is more towards the Excel approach, by which you can find out that how we can get the sensitive analysis report due to with the help of the Excel, and how the shadow prices are uh, can be interpreted. In the next two books, you can find out that how we can apply the sensitive analysis numerically without Excel. So you can find out any means you can find out the details of the sensitive analysis using any of the book. And the last link is for the YouTube video of which you have just seen. Thank you so much.